Hello, Mr. Fry's Algebra 1B. I'm looking at this Unit 5 Homework 6 system word problems. This is not due until March 5th, Friday, but if you're getting started on this, as some of you may be, I want to lead you in the right direction. I have the odd ones done. Go ahead and try the even ones and see what you do on those. And if you make mistakes, don't worry about it. Learn from them and you're making progress. We're going to solve each word problem using a system of equations and use substitution or elimination. You'll notice that I used substitution on all of them just because I did. You could use elimination if you want to on the even ones. If it's easier for you, it just seemed easier for me to use substitution on all these. So number one number added to 3 times another number is 24. So one number added to another number that's multiplied by 3 equals 24. 5 times the first number added to 3 times the other number is 36. 5 times the first number plus 3 times the other number equals 36. Find the numbers. So this is my system of equations. I'm just going to change this to x equals, and I just put the 3y over on this side. I have to change. In essence, I'm subtracting 3y from both sides. Okay, so this becomes negative 3y plus 24 over here. And this is what x equals. This is what x equals. So I substitute this in for my x in the other problem. So this becomes, I could plug that in right there, okay? So I'm going to plug that in right there, and I could work this problem out. I have 5 times a negative 3, and I have 5 times 24, and I have 3y. I combine my like terms. I get negative 12y because negative 15y plus 3y is negative 12y. I isolate the variable. Negative 84 divided by, or I'm sorry, negative 84 plus 12 gives me that. No, that is not right. Yeah, divided by, I'm sorry, what the heck am I thinking? Negative 84 divided by negative 12 gives me 7. All right, I wasn't seeing it properly. I plug in my 7 into the easier problem. Doesn't matter which one you plug it into, you're going to get the same answer. I plugged it in for the y here, and I worked the problem out to isolate the variable, and I get x equals 3. So I get 3, 7 as my two numbers. You're going to want to pause this because that's a lot. Hopefully you're pausing it as we're working through this. For number 3, your family goes to a Southern-style restaurant for dinner. I don't know why. Southern style, you could just be a regular restaurant, whatever. There are 6 people in your family. So x plus y equals 6. Okay. Some order the chicken dinner for $14. So some ordered $14. Chicken dinner, steak dinner 17, some ordered 17, and the total bill was 99 bucks. So that's that equation right there. How many people ordered each dinner? So I just changed this to equal x equals negative y plus 6. I subtracted y from both sides so I could get an x by itself, right? To see what x equals. I plug that x value back into this, okay? And plugging that x value back into this gives me this answer right here. I plugged it back into this equation, that x value. And I work the problem out, and I end up getting y equals 5. Okay, with y equaling 5, I plug that 5 in for y for this problem, and I get x equals 1. When I subtract 5 from both sides, get x by itself on one side of the equation, x equals 1. So 1 and 5. Okay. Could you, thinking about these problems, could you plug this right back into this problem? Negative y plus 6. I'll show you what I'm talking about here. Like this, x equals that. Could you just go ahead and put it right back in there for x? And then I have plus y equals 6. Okay, so when you do that, if I were to put it in this one, you'll notice that, you know, these two, negative y and plus y, I'm going to get 0. And then if I subtract 6 from both sides, 6 equals 6, you know, you get 0. It doesn't work, so you want to get this and then plug it into the next one. Okay, the other problem. I just had a question about that from a student before, and I wanted to show that to you. So going on to number 5, a sporting goods store sells right-handed and left-handed baseball gloves. In 1 month, 12 gloves were sold. So right-handed and left-handed, you know, they sold 12 of them. But the right-handed are 45, you'll read on, and the left-handed are 52 bucks. And the total money they made was 561. So we have two equations here. I'm going to set this x to equal negative y plus 12. I'm just going to subtract y from both sides. Now I know what the x equals. I'm going to go ahead and plug this in to this x value here and work this problem out. I use the distributive property. I combine like terms. I subtract 540 from both sides, and I divide by 7 to figure out what y equals. Once I know what y equals, okay, so that's another step. I have this broken up into steps. I plug it into that first problem because the first problem is easier. I could do either problem here, what I was explaining about the last one, you know, with this little thing. Once you get to this point, I could plug in my y value either here or here. Why would you do it there? You know, I mean, you get the same answer. You get x equals 9, but you know, this would be easier route to go. So you would get the same thing. So x plus 3 equals 12. I subtract 3 from both sides. X equals 9. So we have 9 and 3. X value first, y value next. So how many of each type of glove were sold? So you had 9 right-handed and 3 left-handed. Kind of makes more sense. There's more right-handed than left-handed anyway. So you even have a problem that makes sense. Okay, number 7, airline fares for a flight from Dallas to Austin are $30 for first class and $25 for tourist class. You might think that's pretty low to fly, but you know, they're pretty close to each other, and so that's why. If a flight had 52 passengers, so x plus y equals 52, here's the $30 for first class, $25 for tourist class, and the amount of money that was made. Okay. You could set it up this way. You are going to, and then you'll figure out, you know, how many first class and how many tourist class there were. So I just get x by itself in this problem is the easiest thing to do. And then I get my x value right there, and I plug that into the other problem. Instead of 30 times x, I have 30 times what x equals. So I'm only dealing with y values. I combine my like terms after doing the distributive property. I subtract 1560 from both sides. I divide both sides by a negative 5, and I get y equals 40. I plug in 40, and I subtract 40 from both sides. X equals 12. So there were 12 first class and 40 tourist class. Number 9. At the Holiday Valley Ski Resort, skis cost $16 to rent and snowboards cost $19. If 28 people rented, so, you know, just you had skiers and you had snowboarders, and there were 28 of them. But they spent $16 for the skis, $19 for the snowboards, and the resort brought in $478. So you can compare these two now. So what we're going to do is I'm going to get x by itself so that I could substitute. Like I said, I'm doing substitute on all of these. It just seemed easier. Plug this in for x value. And then I use the distributive property, combine my like terms, isolate the variable. I got y equals 10. Then I plugged in my 10 in for y in the first problem because that looked like it was the easiest. and I subtract 10 from both sides, I have x equals 18. So I have 18 and 10. So there was 18 skiers and 10 snowboarders. All right, good luck on the even ones. Go ahead and try them out. Like I said, if you want to use elimination, if that seems to be easier at any point, go ahead and do so.